Yeah. So in this mixture, first of all, I will ask you all a question. What is the basic idea you have about a mixture? Mixtures are basically, mixture can be homogeneous also and mixture can be heterogeneous also. Yes, you can tell. Very good. Yes. So in the mixture, the elements which forms the mixture, right? They do retain their property. They don't lose it. So it's basically just a physical combination. There is no chemical reaction. Exactly. We can do that. We can separate them by physical methods. All right. I will give you a simple example. Let's see iron and let's take sulfur. Iron and you literally just take it in a petri plate or any plate, right? China dish, anywhere. You just put them together and you mix them. That's it. Now, what will happen when I will take the eye magnet? All iron will get attracted to it. Got the point? And if I take a solvent called as carbon disulfide, what do we take? Carbon disulfide, it's CS2. What it is? If I add a carbon disulfide, you will see all the sulfur will dissolve in it. Iron will remain as it is. Sulfur will go away. That means they were separated by simple physical means, right? But if it was a compound, if it was a compound of iron and sulfur, like iron sulfide, FeS2, okay, or FeS, okay. If this was the substance compound, got the point? You take the magnet near to it, nothing will happen. You take carbon disulfide in this, nothing will happen because now they don't have a individual chemical property. Now they have lost their identity. That's called compound. And separation is not carried out by physical methods. It's not possible. So as long as the individual components have their individualities, until they have their individual properties, they are called as mixtures. If they lose their identity, they turn into a mixture. Understood? No? So, Aditya, you can just put a thumbs up if you have understood. Sanvi, I'll give you a definition. Sanvi, you understood? No?
Yes, sir.
Okay. So you can just write it down. What is a mixture? Let's talk about mixture. What is a mixture? So you can write it down the definition. Combination of two or more substance, combination of two or more substances, which is which could be element or compound. Hope you remember compound means chemically combined. Individual properties lost. Right. So mixture is combination of two or more substance. Who are those substance? It could be element or it could be a compound. Yes. That which is physically mixed, which is, write it down, which are physically mixed, which are physically mixed. No chemical, okay? No chemical reaction. Physically mixed and are not chemically combined and are not chemically combined. So, combination of two or more substance, generally there are elements. which are only physically mixed, not chemically combined. Got it now? With each other. That's it. One more thing. Compounds are present in a fixed proportion. Compounds are present in, like, let's talk about, guys. Now, you all listen to me. Water. See, the water I will collect from your home, from the tap. Then I will collect a sample of water from the RO, water purifier. Then I will collect the water from rain. Then I will collect the water from river. Then I will collect the water from glacier. And then I will collect the water from sea, ocean, lakes. So I basically have collected the water from every water bodies. And you know what? Everywhere it will still be H2O, where hydrogen is 2 and oxygen is how much? Hydrogen is 2 and oxygen is 1 by number. And if I say by weight, then hydrogen is 2 is to what is the mass of oxygen? H2O 8. So if you simplify it, what do you get? 1 is to 4 by mass. You got it, no? H2O, right? So this is a fixed ratio. So when it's a fixed proportion, it will be, when it's a fixed proportion, it will be compound. That's right. Okay. Now let's assume a activity. Suppose I asked all four of you to prepare, because it is summer. So prepare rasna. So what do you add in rasna, you tell me? Or any summer drink? What do you add? Prepare a lemonade now. What will you add in lemonade? Lemon water and sugar. Correct? So four samples of lemonade you have kept. Right? You will see that I tried all four of them. Okay? Do you think all four of them will have exact same taste? Sugar, lemon, and water proportion can be different. But when you collected the sample of water from different places, all were H2O, proportion was same. Two hydrogen, one oxygen, correct? But when you prepared the lemonade, it was all different. Right? We saw that there were maximum people liking her lemonade. Quite obvious reason, the ratio she used was very correct. Right? The balance of lemon and sugar and water. Right? Are you getting it now? So, what is the lemonade? Will we call it compound or a mixture? Yes, it is a mixture. So, proportion not having not having fixed proportion. When the proportion is fixed, we call it compound. But when the proportion is not fixed, not having fixed proportion, that is a mixture. So lemonade is a mixture. That's right. Okay. Adrita, Shanvi, you understood now?
Yes, sir.
Very good. Now let's talk about the type of mixture. So there are basically two types of mixture. Okay. One is called homogeneous and second is called, see, Heterogeneous means you will literally see from your eyes each component. Like I told you, no, you took the iron nails and you took sulfur powder and you mix them. So you can clearly see who is the powder part and who is the sulfur and who is the iron. Correct? But when you made a lemonade, can you see the difference between sugar and lemon and water? They disappear. They become like one. So they look like a compound, but they are not the compound because they are not in the fixed ratio, right? Is it clear? But it doesn't mean we call it compound. No, they are still a mixture. And which type of mixture is there? Homogeneous mixture. So when physical boundary of separation is there, when it's visible, boundary of separation is visible, we call it hetero. Means you can see from your eyes and you can tell this is A component of the mixture, this is B component of the mixture. But when you are not able to distinguish each component, when physical boundary of separation is not there, like your lemonade, right? So we call it homogeneous mixture. I hope it's clear. So let's write down in terms of definition. First, give the headline. We will talk about one by one. So give the headline homogeneous mixture. Okay, homogeneous. So homogeneous mixture. A mixture is said to be homogeneous if different constituents or substance present in it are uniformly mixed without any clear boundary of without any clear boundary of separation. That's it. So mixture is said to be homogeneous when if the different constituents or substance present in it are uniformly mixed without any clear boundary of separation. Example, salt solution or sugar solution. I hope it's clear. Now I will ask you a question. Okay, I'll ask a question later after explaining you heterogeneous also. Okay, or I'm actually curious. Let's ask it now only. Since you know heterogeneous, right? When physical boundary of separation is visible from your naked eyes, when you can literally hand pick and tell, sir, this is carbon, this is sulfur, like that, this is iron, this is sulfur. You can separate them. So tell me, what do you think about air? Is it a mixture or a compound? First of all, clarify me that. Air is a mixture of
It's a mixture.
very good, one more than 1800 gases. More than 1800 gases are present in air. And tell me which is the most abundant uh, substance is present in
Nitrogen.
the air? Yes, wonderful. It is nitrogen. And second most abundant? Oxygen. That's why we are alive. And that's why the life is possible in Earth. Right. Very good. So just like oxygen and carbon dioxide, there are total of 1873 to be precise. Number of gases are there and they are not reacting with each other. That means it is a mixture, not a compound. All right. The biggest proof is why air is a mixture because we are breathing oxygen from the air. If the air would change into a compound, then individual property of all the gases will be lost and we will all die because we will not be able to breathe oxygen. Correct? Is it clear now? Wonderful. Now, so the doubt of mixture versus compound about air is clear. But where do we categorize the air? Homo or hetero? Homogeneous, because you can't see and tell that this there is CO2 and there is O2 and there is N2. Physical boundary of separation is not visible, it's not seen. So when you have a physical boundary of separation invisible, right? In case of air, so air will be a, so let's put the another example, air. All right. Is it clear now? And if you want, you can write the exact number 1873 gases. 1873. Huh? Milk. Okay. So we'll talk about milk. See, milk basically, you will study it later. It's something called as colloids. What do we call it? It's not a mixture, okay? I mean, it's not a homogeneous or something, okay? Basically, understand later on, I mean, you can say that mixture gets categorized into something called as solution, suspension, and colloids. Milk lies here. So for now, we can categorize milk into, because milk contains oil also and fats also, right? Carbohydrates also. Simply, in simple words, I can say that milk contains oil and water. Oil and water. Is it clear? Mixture contains oil and water, and such category where milk lies is called emulsion. What do we call it? Emulsion, and they are type of colloids. But anyways, we'll see them in colloids. We do have it this in chapter, okay, where we have to learn. So we'll study there only. Okay. Okay. Moving forward, you can write air. Anyways, you have written right. Since air has so many gases and it's not possible to identify, right? Individual separate boundary of separation is not there. So it's a homogeneous mixture. Now, next is heterogeneous mixture. Write it down. Heterogeneous mixture. It's very easy. Boundary of separation is clearly visible. Okay. So a mixture is said to be heterogeneous if it does not, write it down, have uniform composition and also has visible boundary of separation between the components. So whatever this mixture is made up of, there will be a physical boundary of separation. Okay. And because there is not uniform composition, not fixed proportion, that's why it's called a mixture, right? Example, you will see sand and common salt. Sand and common salt. You can clearly see the sand and sand grain and the salt grain. You can clearly distinguish between them, right? Sand grain and salt grain. That's right. Sand itself is a mixture, and now on top of that, sand you have added with common salt. You got it now? See, sand basically, if you purely talk about sand, right? If you are talking about sand, which we generally see near the sea, it contains a lot of pebbles, shells, so it forms a heterogeneous mixture. But if you are only talking about sand, not the beach sand, right? Just the sand, then it's a compound. And the formula of sand is SiO2. It's called silica. Okay? Purely sand if you talk about. But if you say beach, then the sand is mixed with pebbles, rocks, shells, right? So then it becomes the mixture. I hope it's clear. Got it, no? But just sand is called silica. And when sand is mixed with a common salt, it becomes because you are able to distinguish the sand and the salt. Salt formula is sodium chloride, NaCl, right? Yep. But if you say, sir, what is only salt? That is compound. Only sand, compound. Formula I've given, right? Because only compounds do have a formula. If there's a formula, that means only compounds have it. Mixtures don't have a formula because there is no fixed proportion, right? Why do mixtures don't have a formula? Because there is no fixed proportions. All right. Uh, I hope it's clear. Shanvi, you understood now? Adita, you got it?
Yes, sir.
Yes, sir.
Okay. So remember another example, oil and water. Oil and the two greatest enemies. Have you seen them together? You will take a glass, you'll add water, you'll see add oil. You'll see two separate layers. Oil will always be on the top and water will be bottom, right? Clear? So water and oil, the two greatest enemies. That is another example. Correct? Physical boundary of separation is there. Physical boundary of, yeah. Another example you can take example number one, example number two, example number three. A mixture of sand and iron. You can also put sand, iron, sulfur, or you can write iron and sulfur. All these are heterogeneous mixture. That's right. Okay. So I believe nobody has a doubt till here. Okay. So now let's try to whatever we have learned, right? The difference between compound and mixture, let's put them in a different table. So construct a, so all of you construct a difference table between compound and mixture. Compound versus mixture. So we will be doing compound versus mixture. So let's write down points. Two or more. First is the definition. Two or more. elements are combined chemically. This is the first point of a compound. Chemical reaction is there. Two or more elements or a compound simply mixed. Elements or compounds are simply mixed, not combined. They are simply put together, not chemically combined. So this is your first difference. The second difference, you can write down about a compound is a pure substance. Compound is a, it is pure substance. Here you can write not a pure substance. Not a, now you can write about the ratio. Elements are present in fixed ratio. Fixed ratio by mass. But here, no any fixed ratio. No any fixed proportion. No any fixed ratio or fixed proportion. Okay. So these three are the very important points. Then you can write compounds are always heterogeneous. Compounds are, they are always heterogeneous. And mixture can be homogeneous or heterogeneous. Can be homo or heterogeneous. Can you tell me one more point? I told you the difference, a very important point actually. I think you told the individual properties. Yes. Not hetero, my bad. Oh, I wrote hetero. My bad. It's homo. My bad. Yeah, they're homogeneous. They have a fixed proportion throughout, right? Homo. And this here you can write that individual property of the components are lost. Individual, individual properties of the component is lost. In the compound, here you can write individual property of each component is present. Okay. Here, last point you can write separation. Separation is not possible by Physical methods. Separation is not possible by physical methods. Like filtration example. Using filter paper won't help you. Got it, no? And here you can write physical method possible. Can be separated. Can be separated by physical method in most of the cases. So in most of the cases, like 98% chances, we are able to separate them physically. So there are many points, but I guess 5, 6 is more than enough. They won't ask you more than this. So you can take a note. Now I'm going to ask you a question, and you will mention which is a homogeneous mixture, which is a heterogeneous mixture, and which is a uh, element, and which is a compound. Got it, no? I hope it's clear. Uh, Sanvi, you understood, no? Adita, so I'm giving a question now.
Yes, sir.
Okay. So you need to classify the following. Classify the following into mixture and its types and elements or compound. Correct? See, when elements chemically combine, they form compound, right? So both of them are pure substance. What they are? Both of them are pure substances, right? Correct. So let's see the question. Question is air, number one, milk, graphite. Remember, graphite is a allotropic form of carbon. You know that, right? It is a allotropic form of. See, carbon is present in multiple different forms. We call it allotropy. What do we call it? Carbon is present in different forms. Like diamond is also a carbon, graphite is also a carbon. Both are carbon. Correct? So hence it becomes, where do you categorize it? Hence it is a element. Yes. Then you have a gasoline. You put in this car, right? Fuel, car fuel. Then you have diamond. Then you have tap water. Then you have distilled water. Do you know what distilled water is? Distilled water means when ions are removed from the water. When it is deionized, when it is ions are removed from the water, there would be some ions present in the water, right? Calcium, magnesium, etc., chloride. Right? When you remove all of these, make it free of ions. It's called distilled water. Okay?
Sir, water is not safe to drink as it can dehydrate us.
Exactly. It is not safe for drinking. Okay? It is used in batteries. It is used in batteries in cars, oxygen. I have done. You know what brass is? Brass is a alloy. Brass is a, and alloys are homogeneous. Very good. Steel, same thing. Steel. Then I'll give you more. Uh, 22 karat gold. See, 24 karat is a pure gold. 22 means there is a mixing. So that becomes also an alloy, right? It becomes a alloy. Iron, sodium chloride, table salt. And I'll write iodized table salt. So try to figure out the difference between 13 and 14. Now, all of you write it down, categorize them, start classifying them. Okay. Guys, did you all get the answer? Please confirm. Everyone, please tell me. What is the air? Can you confirm? Air is a Adrita. Can you tell me the answer? Sanvi?
Homogeneous mixture.
Homogeneous mixture.
Yeah, very good. So, air is a homogeneous mixture. Very good. What about milk? Where do we categorize? It's a mixture, correct?
Heterogeneous.
It's a mixture, correct?
Okay.
Question arises, do you see any difference, physical boundaries there? No. So if you are not able to see any physical boundary of separation, directly you categorize it at exactly homogeneous. See, it does
Yes.
contain fats, it does contains water, it does contain proteins, right? That is the major content of milk, right? Fat, protein, and carbohydrates. But are you seeing them in differently? Is there a physical boundary of separation? No. If there is no physical boundary of separation, direct put them in homogeneous. That's it. So write it homogeneous. Homogeneous mixture. Graphite is a form of carbon. It's a allotropic form of, and carbon is a element. Tell me which group it is. We did in the last class, no? Which group it is? Carbon, carbon. What was the mnemonic I gave? No, 16 is oxygen. Osetepo. Osetepo. That is 16, oxygen. Hmm? No, there is calcium. That's not carbon. Chemistry, sir, gives Sankey problem, group 14. Carbon, silicon, germanium, tin, and lead. So it's group 14 element. Carbon belongs to group 14. I hope it's clear. So it's element. Gasoline, what do you call it? Uh, Adrita, Sanvi, can you tell me what do we call it? Gasoline. Gasoline, what do we call it? We do blending, right? Mixing. So it's a
Mixture,
mixture.
homogeneous mixture.
And can you see a separation? Does the fuel has something different?
Homogeneous.
Yes, no boundary of separation. So, homogeneous mixture. It is a homogeneous mixture. Very good. Okay, diamond is also a allotropic form of, it is also the allotropic form of carbon. So, it is a element. Tap water, any form of water is a
Homogeneous.
no compound. Tap water will be a
Correct.
compound or a mixture. Tell me. I told no water from anywhere. You will collect it. That would be a compound. That's right. So write it down. So distilled water compound. But yeah, wait, guys. In tap water, especially when we consider in Bangalore, you know how tap water is dirty, right? It contains a lot of.
Wouldn't it be a compound along with uh,
Yes, it will be a.
compound that
See,
gets
distilled
mixed with
water doesn't have
H2O or
anything,
something?
right? Distilled water doesn't have anything, so definitely it's a compound, right? It just has H2O, right? But in tap water, we are assuming it will contain some substances dissolved in it. That's why we put it for purification, right? And purification is a physical methods, right? So we can say it is a homogeneous.
Homogeneous
Yeah,
mixture.
yeah. It's actually more appropriate to call it homogeneous mixture. Assuming that tap water has impurities, right? Tap water has impurities, yeah. Assuming that it would be a homogeneous. That's true. Okay. Very good, Aditya. Sanvi, you understood now? Okay. What do we call it for alloy? Sorry, oxygen element. Oxygen is a element. Brass is
Element.
a alloy. Alloy is a remember alloys are not chemically combined. So alloys are not a chemical combination. So it is a homogeneous mixture. Alloys are not chemically combined. Okay. Now, what do we call steel? Same. Steel is also a alloy. So it has the same answer. Clear for everyone? It has the 22 karat gold homogeneous mixture. If I put in front of you 24 karat pure gold and 22 karat gold, you will not be able to distinguish it. Correct? Both looks gold only same. Right? It's the jeweler who says it's 22, 24. We believe it. And we check the hallmarks, right? That's it. But can you see and tell? No. So it is a homogeneous mixture. It is a homogeneous mixture. Clear? Steel, iron. What about the iron? Iron is a
Element.
sodium chloride is a. Now tell me what is this iodized table
Compound.
salt? Yes, very good. It is a
Mixture.
homogeneous
Homogeneous
mixture.
mixture.
It is a homogeneous mixture. That's true. Iodized table salt. Remember, iodine is only source, the only source of iodine is the table salt, the white salt. You know, so it's very essential that you take in the food, right? The white salt, not the pink or any other forms. Those are just alternatives, they don't have iodine. The iodine only source is white salt, okay? Is it clear now? The white is best and it helps you in the functioning of thyroid gland. You know deficiency causes goiter, swelling of the neck, right? That's right, okay? So, how many people got all correct? Tell me. Brilliant. Very good. And how many people got one wrong? Okay. How many people got two wrong? Sanvi, Adrita. How many
Yeah,
people
I
got?
got
How many wrongs you have got?
the tap water and
Tap water.
the
Okay.
last one.
Okay, two wrongs.
I
You
got
got
them all
three.
correct.
So two, three wrong is okay. I mean, more or less you have understood. Brilliant. Okay, very good. Okay, moving forward. Now comes the very, very important question. Guys, this is a VVI question. Yes, the question is how will you how will you justify air is a mixture, not a compound? You have
Because their
to support the
individual
answer, you have to give at least
properties
three
are different.
points. You must give 3 points to support your answer. Give 1 point. Proportion is fixed. Air doesn't have exactly. So air is a mixture, not a compound, because there is no fixed proportion of the gases it contains. Yeah, anyone else who wants to give the answer?
The individual properties of each of the gases
Yes, you both
remain.
are telling yes. Adrita, you are also telling the same thing. Yes. Individual properties there. The best example is we are able to breathe oxygen from the air, and plants are able to take up CO2 from the air for photosynthesis. Right. The gases it contains are not chemically combined. Okay, very good. So you can write down the first answer, composition of air is not always the same. You know, AQI is different at different places, right? Air quality index, you might have seen in the news about New Delhi, right? So composition of air is, is not always the same. At higher altitudes, at higher altitudes, percentage of oxygen drops. Huh. Near industrial towns, air is more polluted. Air is more polluted. This is your first answer to support. Second reason. Okay. Second is major constituents of air can easily be separated. It can easily be separated by physical methods. Okay. You can write these two argument. Third, you can say different gases present in air do not lose their identities. Example, air supports combustion. That is the property of That is the property of oxygen. Air supports combustion. It's a property of exactly. And you can write one more argument that air turns lime water milky. It turns lime water that is CO2 is present. Carbon dioxide is present in air. If air is turning milky, that means it indicates there is a carbon dioxide. So individual property is not lost. Okay, understood? No? So these all are 3 mark questions. It's really good. Now we'll do some more questions. Okay, so everyone's done. Okay, so we'll have a quiz now, and all of you will write your answers, responses. Okay, everyone in your notebook will write the responses. Yeah, just write the answer, don't say anything. Okay, question is not compulsory. You can just read the question. All of you read the question and just put the answer. That's it. Has everyone recorded their response? Next. Done. We'll go to the next question. Okay. Next question now. Is it done? Hmm? Last question. Okay. Now I'll be revealing the answer. So last answer, we know it is C, right? Brass. Done? Now previous, check the answers. Iron, right? Correct? Note it down. Again, one more time. The answer for this is compound. C. Adrita and Shanvi, have you checked all of them? Second last.
Yeah.
Yeah, element. Okay, is it done? And last one, air. C. So I believe you all have got 5 out of 5. Uh, Adrita and Shanvi.
This is out
Yes.
of five.
Yes,
Huh?
sir.
Okay. Did you got 5 out of 5? Okay. So we'll move to the next part. Now remember, homogeneous mixture. You know what do we call homogeneous mixture as? We call it solution. Homogeneous mixture of solution. That is our next topic. Okay. So all of you write it down. So what we are learning in detail now is what is solution. Okay. And remember, you will be studying this again in grade 12. Okay. If you continue with science, you will be studying this chapter called as solution, just solution in grade 12. This is the first chapter of grade 12. Okay. So you can write what is a solution. What is the definition of a solution is? So solution is defined as, homogeneous, a homogeneous mixture of two or more non-reacting substance, non-reacting substances. Solution is also known as true, write it down, true solution. You can simply call it a true solution. Solution is also known as aka true solution. And what is the definition? Homogeneous mixture of two or more non-reacting substance. That is, so we are studying is true solution. Okay. So remember here, in the solution, we have categorized them into, see, solution has two major components. Solution has two major components. Two major component. One is called solute, another is called solvent.
Solvent.
Now remember, solute is basically the smaller quantities. Solute is present in, and solvent is found in larger volume or quantity. I hope it's clear. So, such solution where you have one solute and one solvent only, such solution having only two components. How many components? Are referred as are binary solution. What do we call it? And remember, in our syllabus we do have only till 12th grade. You have to study only binary solution where one solute and one solvent. That's all. You will study only binary solution where one can be solute, one can be solvent. So remember, out of gas, liquid, and solid, you know three states of matter, right? Basic three states of matter, that's solid, liquid, and gas. So now assume that gas will be a solvent, sometime liquid will be a solvent, sometimes solid will be a solvent. So how many such combinations you can make? How many binary solutions you can make with these three phases? We will be able to make 9 binary solutions.
9.
Is possible, right? 3 of gas, 3 of liquid, 3 of solid. Got it, no? Let me show you how. Solute, exactly. Solute and solvent. So first we'll keep solvent gas as fixed. So first solute is gas in gas, liquid in gas, and solid in gas. Remember, yeah, I'll be giving the example. This is one. Second set is, now I'll fix solvent as liquid. So it will be gas in liquid, liquid in liquid, and then solid in. Can you guess what would be the other three? Huh? The other three. 9, I told you, 9 binary solutions are possible. So solid is fixed for solvent now. So gas in solid, liquid in solid, and solid in solid. So this 9 combination, that's how we have got. Clear for everyone? Huh. So first is gas in gas, that is air. The best is air. Got it, no? Then liquid in gas, cloud. Cloud, you can write it down, liquid in gas, cloud and fog. Cloud, fog. All these are liquid in, solid in gas. Solid in gas. Write it down. Yeah, it's like, iodine vapors. You can write it down. Iodine present in air. Iodine present in air. Iodine is basically a solid which is present in air due to sublimation. Result is due to, what is sublimation? Do you know? Yeah, a solid when directly convert to gas, they skip the liquid part. Drita, you are clear now? Shanvi, you understood this?
Yeah.
Yes, sir.
Now we have gas in liquid. So that is cold drinks, you know. When you open the cold drink bottle, it pops, fizzes, right? So that is a cold drink, aerated drink, soft drinks. So write it down, soft drinks.
एक्चुअली अच्छा अच्छा किलो ना मेरा गाड़ी होता है तो
So soft drinks are the examples, okay? That will be for gas in liquid. Liquid in liquid, what is the example? Most of the medicines, even solid in liquid we have, right? What other example you can think of liquid liquid? You know, Adrita, I guess there's some noise. You can just keep it on mute. Ah, very good. Diluted acids. Yes. So you can write it down. Even you can take water and acid, water and alcohol. Water and there are many examples, water and alcohol. Solid in liquid. Solid, yes, that's right. You can write very easy. Sugar water. Sugar solution. Now gas in solid. A gas in solid. That is hydrogen gas present in nickel catalyst. See, in 10th grade, you will study a reaction called as catalytic hydrogenation. It's too early to understand that. But there you will see hydrogen gas is present over nickel, which is the element, right? Nickel catalyst, which is a solid. Nickel is element, it's a solid metal. It's a solid metal, you can write that. Then we have liquid in solid. So that is blue vitriol. What is it? Blue liquid in solid, blue vitriol. Do you know what the formula of blue vitriol is? Copper sulfate. CuSO4 dot 5H2O. Copper sulfate pentahydrate. CuSO4 dot. Yeah, blue crystals, when you keep them in water, it forms this. Okay. Blue vitriol. Write it down. And last, solid in solid. Yeah, you can write solid alloys like steel or brass. I hope it's clear. So these are the 9 possible combinations, the binary solutions made out of solid, liquid, and gas, where each of them are behaving as a solvent. Okay, is it clear now? Adrita, you understood this? Shanvi, is it clear?
Yes, sir.
Okay. Next. See, in the next class, I'll tell you. So this is the you have studied the solution type of solutions, right? Now you will study what are saturated and yeah, that also I will tell you. You know, a sweet people generally see in the shop, jalebis. So when jalebis are made, they are dipped in a sugar water solution, right? That is a super saturated solution. That is a super saturated solution where jalebis are dipped. So saturated, unsaturated, and super saturated. So these three solutions we are going to discuss, and then we will discuss how to express the concentration of solution. Some some terms I'll explain. This contains numericals. This contains. So next class we will be focusing on numericals. So this is the highlight of next class. Yes. All right. So let's keep it till here and we'll continue in the next class. Bye everyone. Thank you.